Mini Lesson 1B, Standard Deviation. To calculate the sample standard deviation, we have S equals the square root of the summation from the first term to the nth term of the individual values in a sample minus the average of that sample. Square each of those terms, add those together, and then divide by the number of terms minus 1. Now, if you wanted it to be, instead of a sample, a population, you would omit this minus 1. The Desmos functions that would be useful here, to find the average, you type in mean and then parentheses, list the numbers. Or you could put a table and then refer to the list of numbers as x1, for example. For variance, you'd have VAR, parentheses, list of numbers. Now, if you want the variance of a population, instead of VAR, you put VARP. And then for standard deviation, if you want it to be a population, you put ST, DEV, and then P. You'd still have that list of numbers. Let's look at the example here. Find the mean, variance, and standard deviation of the following sample data sets. We have 50, 70, 85, and 97. This is a very small data set, so let's go ahead and do this by hand and on Desmos. To find the average, you'll add the 4 numbers together and then divide by 4. And we get 75.5. For the variance, we're just going to find everything for the sample standard deviation, except for we're not going to square root it. So the summation from 1 to 4 of xi minus the mean, which is 75.5, and then square it. And then divide that answer by 4 minus 3, or 4 minus 1. If we write these out, you have 50 minus 75.5 squared plus 70 minus 75.5 squared plus 85 minus 75.5 squared plus 97 minus 75.5 squared. And divide that answer by 3. And when you evaluate all of those, you get 411. To find the standard deviation, you just take the square root of that number. It's approximately 20.3. Now let's go ahead and go over how to do this on Desmos. First, you want to add an item. Let's create a table and put in our 4 values. We'll type in mean, parentheses, and then our list was x1. There's our 75.5. To find the variation, put VAR, x1. You get the 411, and then standard deviation is at 20 point something number. Now, if you want to find the population instead of a sample, just add a P next to variance and standard deviation. What do you notice about the difference between the sample variance and standard deviation and the population variance and standard deviations? Let's look at the next example. Instead of given a sequence of numbers, we are given a scatter plot. Let's go ahead and convert these into values. All right, we'll say that the sequence is 2, 5, and then 8. All right, to find the average, we just add those together, divide by 3. The average is 5. So let's draw a line where that average is. Three. And let's go ahead and find the population variance and standard deviation for this example. The average is 5. The variance would be 6, and then the population standard deviation would be like 2.4. Notice on this example, the mean goes directly through one of these points. Let's look at the next example. We have 3 7s and 1 15. Alright, if we put them into a table and then put them on Desmos, our average is 9, variance is 16, and the standard deviation for the sample is 4. Now notice, this is 6, and these also add up to 6. If you combine the distance from all the points under the mean and all the points over the mean, they should cancel out and give you 0. Here are some distribution shapes you may see when working with data. We have the bell curve normal distribution. That is when the mean and the median are very close together, or even the same. We have left skewed distribution, left tail, and we have right skewed distribution, right tailed. Uniform distribution, where almost everything is about the same amount. Bimodal distribution and multimodal distribution. We'll mainly be focusing on the normal distribution, the bell curve. The bell curve is broken into different pieces. This letter right here, mu, is the average. The dark blue is one standard deviation. And this one's one standard deviation on the other side of it. Two standard deviations, 3 standard deviations, and so on. In general, it's considered to be an outlier or very highly improbable if it's normally distributed and it's outside of 3 standard deviations from the average. Given a normal distribution, what is the probability of getting something within 1 standard deviation from the mean? We'll look at this, and we want to add those 34.1% together. probability of getting something within one standard deviation from the mean is about 68.2%. 2 standard deviations from the mean, you're going to add that answer plus the 2 standard deviations from the mean, so the 13.6 plus the 13.6. Which gives you 95.4%. And then 3 standard deviations from the mean, you're going to take that 95.4% and add 2.1% and 2.1%. And that would give you 99.6%. On a test, 82 is the arithmetic mean and 6 is the standard deviation. What value is exactly 2 standard deviations more than the mean? To find this, we have 82 plus 2 standard deviations more. So it's going to be plus 2 times the standard deviation. Be 82 plus 12. 94 would be the value that is exactly 2 standard deviations more than the mean. What value is exactly 2 standard deviations less than the mean? So in this case, it says less, so it's going to be 82 minus 2 times 6. 82 minus 12. 70 would be 2 standard deviations less than the mean. Find and compare the means and standard deviations for each list in the table below. Alright, so we can go ahead and plug these into Desmos. Let's write list A in the first column. And let's write list B in the second column. For list A, the mean would be 3.5. For the standard deviation, we'll go ahead and use the sample standard deviation, about 1.87. And then let's do the same thing, but this time for list B. So let's call these Y1, Y1, Y1. Okay, so the mean for list B is 3.5, and the standard deviation is about 1.05. In this case, the means are the same, but the standard deviations are not. List A is larger. For a given set of data, the standard score Z corresponding to the raw score X is given by Z equals X minus mu over sigma, where mu is the arithmetic mean of the sets and sigma is the standard deviation. If, for a set of scores, mu equals 78 and sigma equals 6, what is the raw score X when Z equals 2? To calculate this, we'll plug in all the known values. 2 equals X minus 78 over 6. Multiply each side by 6. And then add 78 to each side. 90 equals X, the raw score. There are two different means that could be referred. If it just says average or if it just says mean, you would usually assume for it to be arithmetic mean. That's the sum of the numbers divided by the count, also known as the average. Our formula is A of A equals the sum of the numbers divided by the number of terms. The geometric mean is the nth root of the product of the numbers. Formula for that is A of G equals the nth root of the product of all the numbers. A1 times A2 times and so on.